Yeah, and thanks for the invitation. I wish I could be there with you guys. So yeah, the topic today's topic is how to be build an MLOps platform, and I'm not gonna talk about definitions, bullet points, what are the traits of an MLOps platform or ML platform. But I'm gonna be very practical and essentially talk about the practicalities of you're a small data science team, you start hiring data scientists, and then what you do, what are the challenges, and why MLOps are created. And then the other half of the presentation will be a demo of an MLOps tool that I created, and that essentially was inspired from from all my past work experience. Uh, so yeah, that's the boring stuff about me. I'm gonna very quickly introduce myself. So I'm a staff data scientist at Expedia Group, where I'm leading the reinforcement learning team. Also, AWS awarded me this funny title, AWS ML Hero, because I open sourced Sagify, an MLOps tool for AWS. Um, and I've worked previously at least Workable and Hotels.com. So let's go and start with an example. Let's say that you work in a company, and somebody tells you that oh, we need a product recommendation system. A product manager comes to you and tells you, I want to put a carousel on the homepage where I want you guys to recommend products on our customers when they land on homepage. So then you go through all these questions, right? Like why this ML system is required, what is the scope, how we're going to evaluate it online, is it going to be an A/B test, how we're going to evaluate it offline, what are the metrics that we're going to use, is it going to be precision at K, is it going to be NDCG, if we care about the ranking of the products in this carousel. So all this stuff. Okay, where can I find all the user item historical data, the user item interaction data? How to find the attributes of the users and the items. Then we need to build some sensible baseline so that we have a good benchmark. Are any data scientists, and how many data scientists and software engineers are required for this project? Okay, do we have any infrastructure to train models? How are we going to deploy this model or models? Is it going to be a RESTful service? Are we going to do some batch predictions every day and then essentially cast the predictions on a cache, and these will be served to our customers? How are we going to monitor these models? Before we start the call here, we're talking about all the problems of in the travel industry when COVID became a thing, that almost all of the models at Expedia Groups were invalid because they were trained on different distributions of features. So how can we be sure that the models that we have deployed, or the model, is still behaving as is it expected? How to identify the flaws of the deployed model and improve it? And then how to incorporate new requests from product managers. So the life cycle and the workflow of an ML project is huge. And I borrowed this diagram from Chip. She's a great ML engineer, where she divided the the scope of this project. That you have she calls it data science here. That it's the business analysis, where you identify a business opportunity, like for example this recommendation system, uh, product management, piece where you define the scope, and you see, for example, that in this specific part, also ML plays a significant role. The data ops, where essentially, how can we get all the data? How can we get, refreshed training data set to retrain the model and all this stuff? She calls it ML engineering, the part of, training, developing a model, training a model. And then she says that the MLOps is the part of deployment and monitoring. And, and this is the interesting aspect. I kind of disagree here. Um, I believe that the MLOps shouldn't be part of this cycle. So it's ML engineering and data science, and MLOps is essentially a layer that encapsulates data science, ML engineering, and data ops. And that's an interesting fact about these days, that it's a new area, and we still haven't figured out all the definitions. But let's go and start. Let's say that I'm the only data scientist in this company that wants to build the recommender system. So what I'm going to do is probably create a Jupyter notebook, download some data locally, some historical data, train some models. After a couple of weeks, I will say, oh, this model is really great. Let's deploy it. So then you try to find some engineer in the company that knows about RESTful services, because most probably, well, it's probable that that you don't know how to deploy a RESTful service. It happens that I know, but maybe data scientists know about machine learning, not about software engineering. And then you give this model to the software engineer, and you have to tell to that person, okay, these are the incoming features that should be used when you call the model. This is the output, etc. So that works well when you are alone and you have everything on your local machine. So no need for MLOps or something to essentially streamline this process. Let's say that you hire a second person. Let's say uh, Christos is part of the team now. We work together. So okay, I'm gonna have a Jupyter hub there. So we'll have the notebook somewhere centralized, and that would work for quite a long time. But as the company grows, the teams are growing, etc., and especially the engineering, when the engineering teams are growing, they will get back to you and they will tell you, because you deploy things to production, you need to follow proper practices. So they will tell you why you don't use Git, for example, why you don't use Jenkins, why you don't use some other engineering tools, why you have your code on some on Jupyter Hub, where somebody can change the code, but we can't track the code changes. And then suddenly, the CTO of the company that you work at wants to hire more data scientists, and will become 5. So, and that means that we need to have more iterations of existing models and more models, generally speaking. So as a first time, by the way, I experienced all this stuff. I've worked, I'm working at Expedia Group, where it's like 20,000 employees company. I've worked at Workable when it was like I was like the employee 28, and there was a second data scientist there. And when I left Workable, it was like, I don't know, 300 to 400 employees. And yeah, the first thing that you do is that when you have a bigger data science team, is that forget about MLOps. First thing that you need to do is use Git and just use some kind of template for your code, where every data science project uses, no matter what. So in that way, you don't have different styles of developing things. But then you have another problem. Okay, we have defined the template on Git, and that we're going to use for all our ML projects, but how are we going to track training jobs? So are we going to use some in-house tool? Are we going to build it? Are we going to use MLflow, something else? How about deploying models? Now, because we're a bigger team, we have 10 models that we want to deploy. So the engineers from other teams will be like, I don't have time for you. You figure it out. I have other things to do, for example. So how are you going to deploy them? How are you going to get help to find the right architecture? Because sometimes you need to have batch predictions, sometimes real-time predictions with RESTful services, sometimes streaming-based predictions. Have a link here, for example, if you want to deep dive into that. How about monitoring deploy models? Okay, let's say that somehow you manage to to deploy a model. How are you sure that it's healthy, like it's not down and affects the business, and the CTO will get angry with to you? How are you sure that it's making good predictions, or the input features have drifted? So, and many more challenges that I'm pretty sure that you're facing, or you have faced in the past, or you're gonna face. So, and that's why we need MLOps. So we need some best practices, some tools, so that as data scientists we focus on machine learning and not on low-level engineering tasks, or how to keep track of things like code, data, training jobs, results, communicate things to our colleagues, to our data scientists, communicate results to product managers, to senior management. So that's why I wanted to give you all these challenges here that I have faced personally in the past, and to understand why MLOps is required and what kind of problems MLOps solves. So how do I start? We are five. you know, let's say that, I'm the lead data scientist. I need to make some decisions. So, okay, we recently switched to cookie cutter DS template, Git, perfect. So every project follows the same pattern, sweet. Um, but deploying a model requires engineering help, and it's tricky to find data scientists with coding skills and be great at the same time, in ML. Probably they work for Facebook, Google, Amazon, so you can't compete with them, right? In terms, of salary and problems and this kind of stuff. Um, and maybe you're lucky. Maybe one of your data scientists has software engineering skills that can do that. But do you really want to, for that person to spend, time in engineering and not in data science? So you have some options. So you can hire software engineers to build MLOps tools. So that's, you have to justify to the CTO why, how many it's going to cost you. And, because the an ML platform essentially doesn't, is not close to the revenue. It's an enabler. How are you going to essentially justify this investment to the CTO? Okay. Another option is to go and buy an MLOps platform. So there are many startups out there that do really great job, but there's always the risk that these are startups and you don't know if they're gonna disappear in a year from now, and many of them will disappear, statistically speaking, and many of them want you to be locked in their platform so that it's not difficult to go somewhere else. How about using some open source MLOps tools? That's really good option. But still, you need to do some engineering work to integrate all these things. And of course, there is a combination of the above. Just to let companies like Facebook have built everything from scratch. They built their ML platform from scratch, and that happened like 6 years ago. Other big tech companies, like Expedia, we have used some in-house engineering tools, some open source tools, but at the same time we have software engineers that integrate all these pieces together and we have an ML platform. So the key the key thing here is to be use case driven. So in this specific point, what we want to do is to easily deploy models as RESTful services, and that's the only thing that matters right now. We don't care about getting fancy and training models in a distributed manner, or we don't have complex models like PyTorch models or TensorFlow. So we need to be very strategic here. So we have some options. Either we're going to go to Sagemaker, GCP platform, Seldon.io, and pay them, and they do really good job on deploying models, or we're going to go open source, like cortex.dev. That's really cool piece of software, by the way. ZenML, really good, and Sagify, like mine open source project. So the latter two, ZenML and Sagify, they rely on paid backend engines like SageMaker and AI platform, but they offer you the open source abstraction layer on top of that. So what you need essentially is, in this template that you have adapted, to someone, implement a predict function, where essentially what you do in the predict function, you say, okay, I'm gonna load my model, I'm gonna write the required prediction logic, and then I will return some JSON, let's say, some prediction in a JSON format. And then ideally, in a dream scenario, I want command, that's command from Sagify, but some command that where I will say deploy, you specify, the model, or let's say on S3 or locally, you specify the number of machines that you want, in that case 3, and the type of the EC2 machines. And then automatically, that should essentially deploy your model on AWS, for instance. So and that way, as a data scientist, you focus 100% on training, and you don't care how to put the model into production. And that's the most primitive form of an MLOps platform, essentially. Later down the line, while you have more successes as a DS team and you hire more people, then probably you get fancier when it comes to training, more sophisticated models. You probably need some horsepower to train these models, on bigger machines with more data, etc. So that means that you need some new command line where you specify where all these data lives on S3, where let's say my bucket training data slash where on S3 to save the train model, let's say my bucket slash output, and what type of machine you want to use for training these things. And then locally on your machine, you have defined your training logic. And that command line, again, automatically will, pick up the code, automatically copies the code to the cloud, spin up EC2 instances, copies the training data to the EC2 instances, triggers the training logic, saves the model locally, and then saves it on S3. So that's the more sophisticated view of an MLOps platform. And later on top of that, you start adding things like, okay, how to identify biases on my model, or when you have deployed the model, if there is some drifting on the predictions or some drifting, on the input features. So at the end of the day, be strategic on the buy versus build. Software engineering salaries are quite high. I think it's interesting days that it's easier to get funding for your startup than finding a really good software engineering talent. And it's not only about building an internal MLOps platform. Keep in mind that you have to maintain that. So that's a really, really painful thing to do. Yeah, big tech companies have, dedicated ML platforms like Google or Facebook, but, they have like, tens of thousands of engineers to do that. And, some other big companies like Expedia, we use a combination of the latter options that I've explained. And, you need to do some financial analysis as a lead data scientist in order to help, navigate and find the best solution and sell it to the senior management. So in my personal opinion, the main factor of ML success in a company is when you enable your data scientists to focus 100% on machine learning. That's the key thing. Think about, somebody that works, let's say, at Facebook compared to somebody, in a small startup. So the guy at Facebook is capable to train, I don't know, tens of models every day. And then the guy in a small tech startup, struggle and, they manage to put into production only 2 models in a year. obviously you can't compete. So you need to be strategic in order to be able to compete with them. So and one important thing, that the last point is that the ML platform in the company, it's going to democratize machine learning and the predictions in the company. One example of that is that, for example, at Expedia, all of our predictions of the models are saved in a cache. So essentially, everybody in the business can, query these predictions, these scores, and use them for their own use case. So you don't have to call again the same model, or you don't have to go and find me on Slack and ask, questions how to integrate with your model. So my opinion, use some ML engine from an established cloud provider like Sagemaker. Build a simple abstraction on top of that to hide all the details from data scientists. For me, Sagemaker is great, but it's still like IKEA with really bad instructions. That's why I open source Sagify. And in this way, because you have the abstraction, you can change the underlying engine in a painless manner. So yeah, I'm gonna show you now a demo of Sagify. It's it's on YouTube. I don't do live demos because 95% of the cases something wrong is happening. So yeah, I'm gonna show it now.
I'm not sure, but I'm not hearing anything from my side.
Oh, you're not hearing?
No.
Oh, okay. Sorry, guys. How can I make this happen?
You're probably gonna have to share again, tick in the checkbox for share computer audio or something, like when you're gonna share your screen.
Oh, thanks. Okay, I'll stop sharing and reshare again. Thanks. First.
At the bottom left, I guess, is the checkbox, like share computer sound. You have to enable it.
Okay. Advanced sharing options. I don't see anything like that.
You can share your screen though, right? So then just click the green share screen button as you would normally. Then it's gonna pop up a screen, and then it's gonna say, yeah, if you want to share screen one or a program.
Oh, got it. I found it.
Yeah. Okay. Good.
Sorry. Thanks. I open source. Did you hear now the sound?
Yep.
Okay, perfect, cool. Yeah. How many data scientists are required to do this? And makes it very easy to train, deploy, perform hyperparameter optimization on Sagemaker, just using a few commands.
Okay, pretty cool. So what's the elevator pitch for the demo? What are we gonna run?
So we are going to build a classifier on the iris dataset.
Okay, so no MNIST, thank you.
No MNIST. Another boring dataset. And then train it on the cloud on Sagemaker, and then deploy it as a RESTful endpoint on Sagemaker as well. And we're going to do it in maybe 10 minutes.
All right, let's go.
Yeah,
the floor is yours.
Thank you. Let's do this.
I will just ask silly questions.
Cool. Let's have a quick look on the dataset. It's called Iris dataset. I'm pretty sure many of you already know that. It's about finding which class of iris flower every sample is. It consists of 4 attributes or 4 features.
Okay.
And it has 3 labels.
Okay. So 3 types of flowers, right?
Exactly.
Yeah. Okay.
So you can see here the data set. So 4 features and the label.
Okay. All right, fair enough. So you're going to learn about flowers too today.
Exactly. So the data set is on S3. I'm trying to make it very realistic for real world. So most companies have their data on S3.
Sure.
So it's under Sagify demo, and here is the iris data.
Okay. Just a text file, right? Just a text file.
Exactly. Exactly. And then I'm going to GitHub, and I'm going to create a new repository.
All right.
We're going to call it Sagify demo.
All right.
Let's do README. Let's have an ignore for Python. That's it. Let's clone it. Cloning the repository.
Okay.
Getting into the repository. And then we need to create a virtual environment, as well as in Python projects.
Sure.
I usually
Practice.
I usually use Anaconda. So it's Conda create.
And you could do this on a notebook instance as well, right? Because we have Conda pre-installed if you.
So it looks like I have already the environment, but I'll create it from scratch.
Okay. Yeah, if you're not familiar with Conda, it's basically a Python package manager, and you can just simply create different environments. So let's say if you want to have a self-contained environment for, let's say, TensorFlow, you can build that. And if you want MXNet or another TensorFlow version, you can isolate your environments and avoid doing what I've done on countless occasions, which is work with a single Python environment and destroy it because you upgrade a package that doesn't work and you break dependencies everywhere and you have to install everything from scratch. So you guys are smarter than me and you use Conda now, right?
Exactly. So I created the environment. We're going to activate it. Let's clean our terminal. And then we have to install the dependencies. So of course, we need to install Sagify.
Sure.
Scikit-learn.
Yep.
Pandas, usual stuff. And AWS CLI. Did I forget anything? I think we're good.
Okay.
Let's install them.
And of course, we're showing the steps, but you would have your script to.
Exactly.
You would have your script to do all that stuff automatically, right? All right, almost there.
Yeah.
Oh, Bodo core, yeah, of course.
Yeah.
That's actually the important one.
It's required for the AWS CLI.
Yeah.
Almost.
Okay, This should be done in a few seconds.
Yeah.
Right? Live demos. You're going to see everything. Right?
Cool. The Python environment is installed. So we're going to run sagify -- help and see all the commands here. So we see like build, cloud, where we can upload data using the cloud. We can train the model and we can deploy it on Sagemaker.
Okay.
But first of all, we're gonna.
That looks simple enough. I mean, I could probably use this.
Exactly. The first thing we need to do is Sagify init.
Okay.
So essentially, we're creating a new project, and it asks for the name of the project. So we're going to name it, of course, Sagify demo. It's a new project.
Okay.
Python 3, of course.
Yes.
And then it's really cool because it will ask you for all the AWS profiles that you have locally. I'm going to use the ML Hero profile.
Okay, so these are AWS profiles defined in the AWS CLI config file, right?
Exactly, exactly.
In your home directory .aws/config.
Exactly.
Okay, yeah, all right. Okay, so the point is you get the credentials that you need to get the job done.
Exactly.
Okay.
And you can change them whenever you want.
Okay.
And then your desirable region name, US East 1, the default. Sure. And then you have to define where you have installed the requirements.
Okay.
So it was the requirements.txt. Can we pause here?
Sure.
Yeah, okay. Because I forgot to.
Yes, I just realized it. Okay. Okay.
Perfect. So we have created the project, and then we're going to use PyCharm to just open and create the training and predict logic. So let's use PyCharm. So we're going to open a new project, documents.
Okay.
Here we are. So it has created a source directory. Under this, we have Sagify, and then it has all this boilerplate code, like the Docker file, everything that you need to essentially train your model on Sagemaker.
All right.
And then you have to go to the train file, and if you scroll a bit.
Okay, zoom in a bit, because that's probably hard to read. Yeah, great, thanks.
There is a train function.
Okay.
And then you have input data path. This is where your training data will live. This is where you're going to save your model.
Okay.
This is optional if you have passed the hyperparameters through a JSON file.
Okay.
And this is where you're going to save any failure. So you see here to-dos. So essentially you have to replace these to-dos with your modeling logic.
Okay.
So let's do that. So first thing is that we're going to import pandas. And we're going to read the training data.
Okay.
So data frame, PD, read, CSV. It was a CSV.
Sure.
And then what we're doing here is we're concatenating the input data path.
Okay.
And then remember the iris data file?
Yes.
It was called iris.data.
Okay.
Essentially, that is the full path to our training data.
Okay.
And then the next step is to say that there was no header.
Yeah, no column names.
Exactly. And then the new column names, I'm just going to call them fit1 for feature 1,
Okay.
fit2, fit3, fit4, and then the last one, of course, the last one is the label.
Sure.
Cool. And then X is going to hold the features only. We need one more bracket. Y is going to hold only the labels.
Okay.
And we do dot values to essentially get the NumPy array.
Sure.
Okay, almost done. So then it's a good practice to train the dataset into train and test dataset. So from scikit-learn dot model selection, we import train test split.
Yeah, that's a good one to know.
And also we are going, before we're going to the modeling side, let's split the data. I forgot that. So train, test, split, and we give the x, y, then it's the test size.
Sure.
So 30% of the data will be used as a test data set. And then it's a good practice to use the random state.
Yeah, to avoid splitting in the same way all the time, yeah.
Exactly. And then we're going to use support vector machines. It was a big thing 15 years ago.
Yeah, it still works. So while Pavlos is doing that, so here we're kind of skipping steps in the sense that, of course, you would probably write and experiment this code on Jupyter in a notebook, either locally or a notebook instance with a fraction of the data set. Here, it's obviously a very small data set, but imagine you have 100 gigabytes of data. Maybe you would grab 1 gigabyte, write this code, make it work, and then train it on Sagemaker to scale, right? So if you're new to machine learning, we would actually probably write this code first, debug it, test it on a subset of the data set, and then once we're happy that it works, we want to train at full scale, and we would just integrate our working code into this, right?
Exactly.
That's probably what you do, right?
Exactly.
Okay, yeah. Good.
That's the process. So these 2 lines, and we just trained an SVM. So simple.
Okay, yeah. Scikit-learn is brilliant.
All the math is hidden. So then we are going to evaluate that. In order to evaluate, so we have to essentially make predictions on the test data set.
Okay. And compare 2 labels, of course.
Exactly.
Yep.
So X test. And we're going to use the accuracy metric for that region. So again, scikit-learn dot metrics.
Yep.
Import accuracy score. And then the accuracy equals accuracy score, where we give as the y true is the y test.
Yep.
And then our predictions. That's perfect, right?
Yep.
I think everything is done. And then the final bit is that we need to save the model.
Yes.
And it's a good practice to save also the accuracy in another file,
Okay.
like our report.
Yes.
So from sklearn and externals, we import something called joblib that will help us to serialize the model and deserialize it later. So we need to construct the model path, which of course is going to be the concatenation of the model save path.
Yeah, that's an important bit, and sometimes it confuses people who get started with Sagemaker. You have to save the model in a very specific place. Okay, so Sagemaker will actually tell you where to save it, and so you have to use that path, which is local to your container, and then at the end of the training job, once that code has saved the model locally to the container, Sagemaker will actually take the model from that location and copy it to S3, right? In the S3 prefix that you defined in your training job. Okay, so a lot of people say, "Oh, my training job failed." The training job itself probably worked, but you saved the model in the wrong place. So Sagemaker doesn't find it, and of course it fails. Okay, so pay attention where you save the model. Okay, just
exactly. And here it's hidden. Lesson. You just need to save it somewhere that you don't know exactly what is it. And then you do joblib.dump, you pass in the classifier that is trained and the path to save it. It's going to be saved in a file called model.pkl. And then we need to save also the accuracy in a file. So we're going to do it in a simple way. Again, we have to define the report path. Is again going to be in the same location where the model is saved. and we're going to call it report.txt.
Okay, super simple.
And then with open the report path, and we want to be able to write there as f.write. We stringify the accuracy. It's going to be a float. And I think it's almost done. We have the usual indentation problem in Python.
Tabs or spaces? We'd need a full conference on that one.
It's reformatted. Okay.
All right.
Cool. Perfect.
Okay, so we're ready, right?
Yeah, exactly.
So loaded the data set, split it, trained, support virtual machines, and scored, and saved the model and the score, pretty much.
Exactly.
Yep.
That's it.
Okay.
So let's go into.
And if you're not familiar with sklearn, we had a session today on that. Okay. So yeah. So looking at sklearn and typical algo. So go watch that one, and then you'll understand everything in there.
That's perfect. Cool stuff. So then what we need to do is do Sagify build.
So let me guess. Yeah, it's building the container based on the boilerplate code and the code we added, right?
Exactly.
Okay.
Exactly. So it will take some minutes. So yeah, the Docker image is built.
All right.
So now we are ready to train the model on the cloud.
Let's go.
So it's really easy. It's Sagify, cloud, train. And then you have to specify where on S3 the data lives. So it's S3, Sagify, demo. That's it.
Okay.
And then we have to specify where exactly to save the model and the report.txt file. So it's going to be in the same bucket, but under output.
All right.
And then we have to specify the EC2 type.
Okay.
And it's going to be, I don't know, just randomly chosen ML M5 large. Probably it's too big for that task.
Okay. Do you support Spot instances?
I think they're supported now. But
They are in SageMaker, but does the tool allow for that?
No, at the moment.
So pull request.
Pull request. I'm waiting for that.
-- spot. Okay, or -- enable spot. All right. Pull request, please.
That would be really nice. It will save me a lot of money.
All right. Here we go.
That's it. So here it says no IAM role provided. It's okay. It uses the one that we used in the beginning, the ML hero. But if, let's say, you have changed the profile, you can pass in one here, a different one. Okay. It's a completely dynamic. And we get the logs here, so it's starting the training job. So if we go to the AWS console, and go to Sagemaker.
Yeah, we should see the training job, right?
And go to the training jobs.
Hopefully.
We see that there is one training job in progress.
Okay.
And we see here that the training has been completed.
Okay.
And the logs in red essentially are the logs from our training logic.
Okay. Okay.
So the training is successful, and we can see here the S3 location.
Okay. All right. So no difference from using the SageMaker SDK here. I mean, we get the model artifact as a zipped tar file. So okay, if you know SageMaker, you know this.
And then what we need to do is to go and deploy that model as a RESTful endpoint.
Okay.
So it's really simple. What you do, Sagify cloud deploy this time. And of course, you have to specify the S3 model location.
Okay.
So S3 model location. Our favorite copy paste.
Yes.
And then we have to specify the EC2 type. Let's use a small one, T2 medium.
Okay.
Then the number of instances, let's use 1.
Okay.
And then we can give also a name to the endpoint. Let's call it my awesome endpoint.
Yes, because it is. Here we go.
And that's it. Awesome. The endpoint is deployed. We can see that from the logs.
Okay.
So we can go quickly to the console and see my awesome endpoint.
Yep.
See?
In service. Nice. Okay. Nothing happening yet, but all right.
Cool. And then if we go to our favorite postman,
Yep.
and send the features.
Okay, so now we pretend we drove somewhere and find an iris flower and we measured those 4 dimensions and we want to know.
Exactly, and see what type of iris is it.
So let's go.
Okay, we're gonna call the endpoint, and here you are.
It's a Setosa.
Setosa. So simple.
Okay, so yeah, HTTP posting to the endpoint.
Exactly. So yeah, guys, that was a demo of Sagify, and it's it gives you a flavor of of the interfaces that usually ML platforms have in some of the big tech companies. So yeah, that was the presentation. It took a while, but well, we don't have probably nothing else to do these days. So yeah, thanks.
Thank you very much, Pablo.
Thank you.
Thank you, Pablo.
Any questions? I see some questions in the chat. Maybe easy one from Murillo, whether you can share the presentation deck, Pablo.
Oh yeah, absolutely. I'll share it with you guys, and then are you gonna post it on
We can post it on Meetup, yes.
Cool.
And there is a question from Ganesh, whether Sagify, if it supports step functions.
No, at the moment.
I have one question, and it's about, I mean, you deploy the REST endpoint, so you call the API, and how does it work if you want to update the model? So with this Sagify, do you have a downtime, or is there a way to handle it somehow?
Yeah, that's a good question. So yeah, at the moment, if you redeploy that, you may have a little bit of a downtime. So one way to do that is to essentially version use some kind of versioning of the endpoint name on the flag that it has. And so every time you create a new one, you can say v2, v3, v4. And then once it's deployed, you can go and delete the previous one.
Okay, yeah.
And does it work for batch processing, or how do you deal with that?
Good question. Yeah, there is one more command, Sagify Cloud. I think I call it batch transfer or batch prediction, where essentially once you have deployed the RESTful endpoint, you can specify in the batch prediction functionality an S3 location where you have all the features, the name of the endpoint, and where on S3 to save the predictions, and it's done for you automatically.
Okay, cool. And then how do you deal with the separation of concerns between feature engineering or preparing features and creating features and storing them on S3 versus training? Do you deal with training thinking about getting everything ready for you and then only spinning up something for like as a framework, the hyperparameters and blah, blah, blah? How do you deal with these stuff,
Yeah, there are many schools here. What I've seen working really well is to have a complete separation. So with the feature engineering part, where essentially, you may have, a complex, Spark job that generates the training data, and you save them somewhere in S3, and then if it is batch prediction, is perfect. You can reuse the same batch Spark job to generate the features for prediction. It's getting tricky when it comes to if your website wants to call this, because they have to follow the same logic for essentially calculating the features. So here, ideas like feature store can help, for example. But yeah, it's I think that's a very big discussion. I think how to do it properly.
Cool, thank you.
Sure.
There's one more question, Pavlos, in the chat, which is from Minas. He asks whether there's a provision for online training.
Online training, so it's not supported like easily. So what you can do is, I've seen that with contextual multi-armed-bandits, where essentially you have to incrementally train a model. What you can do is that in the training logic, you have to load the previously trained model, do an incremental train, and save it back on S3, and have some kind of wrapper job that finds that it runs. I don't know. You can have a lambda where it runs, I don't know, every couple of minutes, checks if there is a latest saved model on S3, and if that happens, then you deploy the new version. If it's deployed, then you delete the previous one, and you move like this. So it's not real-time online. It's like mini batch online learning.
A follow-up on that, actually, is that a limitation of Sagemaker? Not so much of the tool, but more so the platform at the moment.
Yeah, it's a limitation of all the ML engines, to be honest, at the moment. So they all of them were designed in this format that of classic supervised model, where you always separate the train test, and you do some you build new models, I don't know, every day, maybe every hour at most. But yeah, they haven't solved the real time online learning, to be honest. Maybe you want to build a startup.
There's one more question in the chat. By the way, feel free to open your mics and ask the questions if you want, but I'm happy to read them as well. So Valeria is asking, how would you handle requests while you are deleting one model and have not yet deployed the new one?
Yeah, that's a good question. So yeah, because if you add new features, to your model, that will be able to serve your still serve request, the old model. So that will be for a small time, you may have like really weird predictions. But if you have completely changed the features, yeah, you need to synchronize when the client side is going to call the new model in order to do that. So here we're talking about more tricky stuff, where your engineering team needs to you need to coordinate with your engineering team. So yeah, it's blue-green deployments, this kind of stuff on SageMaker can be tricky, or in fact on most ML engines. I think the one tool that is really cool is the best one in deployments is Seldom.io, to be honest. They're the most advanced, but they focus only on deployments.
I have a question for you, Pavlos.
Yeah.
So Sagify is an abstraction on top of SageMaker, of course. Are there any thoughts on extending that to GCP, maintaining the API, but using a different backend?
Yeah, I want to do that. I don't know if you guys want to step in as contributors. So yeah. By the way, yeah, if you want to step in as a contributor, just ping me. Just that I didn't have the time yet to do that. But that was the whole premise of Sagify, that it will be the abstraction on top of GCP as well, or any other ML engine that is out there.
Cool. Any other questions from anyone in the chat, or feel free to open the mic and ask, of course.
I have a small question. If you are to integrate this in like a CI/CD pipeline, what would be like a simple example for how would you go about doing that?
Okay. Yeah. I mean, yeah, it can be like Jenkins, anything. So what you could do is that you could have like one Jenkins job that is responsible to to find new training data on S3, specific, let's say, on latest date, if you have split the paths on date, and then essentially call either emulate the call to the terminal, say Sagify Cloud Train, but also have the Python APIs, so you can do it programmatically if you want that. And then wait until the model is trained. That's the tricky part with Jenkins, because it may time out. And then later you can have one more step that essentially, if the first one is successful, you deploy the model. So it's we are used to have, like in CI/CD, the build, test, deploy. So now you have the build, train, deploy.
Cool, thanks. And if I understand correctly, if you start the training process, it doesn't sort of start it and then drop back to the terminal. It will sort of wait until it's.
Oh, you have an option. You can wait. It can hold, or it can trigger it, and then you can continue.
Okay. Is there a way to sort of monitor it while it's training, or that goes back into Sagemaker essentially?
Yeah, you have to go to Sagemaker. So yeah, so so many things that we could do.
No, yeah, I know you. But okay, cool. So it's back to Sagemaker.
So yeah, you can. The Sagemaker SDK is fine. Just it has become gigantic, and yeah, you can monitor training jobs. So this is quite easy. You can see if it is in progress, failed, success, etc. So that's quite easy.
Cool. Thanks.
Yeah, sure.
There's another one question on the chat that says whether there are any resources that you can share with us in regards to MLOps. For example, who to follow on Twitter, any blogs, podcasts that we can sort of read or hear after that if we're interested to hear more, to learn more.
Yeah, cool. I'll add one more slide with all these resources. So when I share the slides with you guys, it will be everything on one place.
Perfect. Any other questions? Anyone? We have some more time. I had yet another question for you, Pavlos, which is, how does Sagify or another tool as well, but how does this MLOps framework work with DVC essentially? Like DVC nowadays doesn't only handle, it allows you to retrain. Maybe there is a way that you can use some of these tools to throw back the reproducibility pipeline on the DVC in the cloud, but also there is a CI/CD for machine learning component of DVC. So is there any way these two tools can work together, or they don't combine very well?
I mean, you can, as far as I remember, you can also version data with DVC. So that's a good thing where you can complement that aspect that you don't have here. So you can start versioning this thing, and you can version the output, so the model that is saved on S3. So then you have a really good lineage that tells you, okay, I versioned the data set. I know that that was a Sagemaker training job that was used, and then the model output is this one. So you can essentially use it on top of Sagify. So I could see this this scenario to complement the two of them.
Makes sense. Any other questions? In which case, Christos, should we say thank you and say bye and stuff?
I think so. So if you notice in the chat, there is a link to a Slack channel we made. We creatively named it PyData. So if you want to join, I mean, we're trying to really build also the community here in Cyprus. It would be nice if we can discuss in there. So feel free to, the invite is there, feel free to join.
Cool, that's perfect.
Yeah, I guess with that, yeah, have a good night.
Cool, thanks guys.
Thanks everyone for
Thank
joining.
you very much, Pablo. Thanks everyone.
Thank you.
Bye.
Bye-bye.
Bye-bye.